Okay, before I proceed to another example on the triple integral, about the application of triple integral, it is about the spherical coordinate again. Okay, last time I already show you, if we have, let's say you have the ice cream cone like surface where it is a combination of the cone. Okay, let's say your cone is given by z equal to x squared plus y squared. Okay, there is a cone concave up, and then you also have the surface of the sphere given by, okay, the simplest one maybe I just give a 4, so you have a 2, so meaning that so you have the cone and the covered by the okay, covered by the sphere. Okay, this is part of the sphere with radius 2, z, x, and y. Okay, so this one, if you're talking about the phi, so let's say we want to get the volume, so then our formula is this one, and then your formula is then rho square sine phi d rho d phi d theta. So the limit of theta 0 to 2 pi, and then the phi. Okay, the phi, because you have this one, I already show you the phi of this particular cone is pi over 4, isn't it? Okay, so you get 0, because you can see here your cone is concave up, and it is symmetrical or lying along the z-axis positive, as we know that the limit of phi, this is about the limit, the range. Okay, the range of phi is 0. So how can we measure the phi is 0? So it is starting at the z-axis positive. Okay, so as you can see here, the z-axis positive is lying inside or be part of the solid that we have. So then the smallest phi is 0, and the highest phi is depend on this line. So that line is basically from this cone, and this cone give the phi equal to pi over 4. So the limit of phi for this particular cone is 0 to pi over 4. So then you can put pi over 4, and then I do this mistake here. So rho is 0 to 2, and then you can compute the volume. Okay, how about if you have so this one is given by positive square root. So let's say they say that find the volume if the solid is bounded by the negative square root of x squared plus y squared, and also the same sphere with radius 2. So how can you sketch that? So now your sketching then becomes, you have a cone concave down, right? You have a cone concave down because now you have a negative sign here. So now your cone looks like that, and then because for this particular surface we have a complete surface, right? So we have that one positive, and we also have a negative one. So now our ice cream, so we only have the cone, and in this case our ice cream which covering the cone is this one, which is part of the sphere with radius 2. So this one minus 2. Okay, so now this is your ice cream cone like surface but concave down. So now when you want to compute the volume, okay, let's say volume, but because that is the simplest one, but maybe sometimes they ask you to evaluate the triple integral. Okay, so you have to just you have to have the integral here and dv, isn't it? So let's say now the simplest one, we want to compute volume. So now everything will be the same. You have rho square sine phi d rho d phi d, I always do mistake this, d rho d phi d theta. So all the limit for rho and theta is the same. So theta 0 to 2 pi, and then rho still the same, 0 to 2. But then your phi, so your phi here, because now it is at this area, so no more z0. So as you can see that, how can you determine the angle for the phi? So this is the z-axis negative, right? That is the line, z-axis negative. So now you have to find the angle for this. So as we know, this one is at 3 pi over 2, right? 270. And this one is if the positive cone, where there is a cross over there, so that value is 45 degree, then what is the value here? So this one is supposed to be 45, right? But you cannot put 45. You have to put an appropriate limit. So the highest value is 3 pi over 2. That is the highest value of phi, the possible highest value of phi, which is sorry, forgotten. This is about phi, not theta. Okay, so this is not 3 pi over 2, but we are talking about the phi, right? When it is a phi, so for the angle of phi, and this one is supposed to be pi. Okay, so how you read the phi? So this is z. This one z-axis is positive, and this one z-axis is negative. So this is the angle. How you read the angle of the phi? We are talking about the phi. So this is for phi. This is phi equal to 0, and this is phi. The highest one is pi. Okay. So now since since now your line here, this one is 45 degree, or pi over 4, or pi over 4. So you have to find the angle for this, so that you know this line belongs to phi equal to, how can you get that? Pi, so pi minus pi over 4 will give you 3 pi over 4, right? Is that correct? So okay, so now your phi here is 3 pi over 4. So 3 pi over 4 is equal to 135, right? Okay, 135 degree. So the possible phi, the highest pi, as we know, it is pi. Okay, and at this cone, so the angle is at 3 pi over 4. So 3 pi over 4. So you have to put 3 pi over 4 to pi. Okay, 135. Okay, so this line which is part of the cone is at the phi equal to 135 degree to 180 degree, or normally you put in radian, so then you have to put this one. So if you evaluate the volume, so I'm sure that if you put as the answer will be the same, because the size of them are the same, and the answer will be the same. But you have to be careful when there is integrand here, and the answer, if you put 0 to pi over 4, or if you put 3 pi over 4 to pi, and the answer will be not the same, because you have the integrand here. So it depends on whatever function that you have. So your calculation, I never tried it, but I'm sure the answer will be not the same. But if we are talking about the volume, so volume, because of, we know that even though you have a similar size, so for any direction, so the answer will be the same. Okay, so that is about the how you choose the phi.